In this video, we're going to apply the performance evaluation techniques studied in the previous video lecture to two funds, Fidelity Magellan and Berkshire Hathaway. The Fidelity Fund used to be run by Peter Lynch, a very successful investment manager, while Berkshire Hathaway is run by Warren Buffett. We're going to analyze in Excel whether these two funds really do outperform. Do they have skill? Do they earn abnormal returns? The first measure we're going to look at is Jensen's alpha. We've seen this measure several times before now in class. To calculate Jensen's alpha, we're going to have to run a regression. The dependent variable will be the excess returns on the funds, and the independent variable will be the excess returns on the market. The CAPM implies that the intercept, or Jensen's alpha, should be equal to 0. If these funds do perform abnormally, then we might expect the alpha to be greater than 0. That's what we're going to look at. Let's shift over to Excel then. Here we have returns for Fidelity and Berkshire. We also have the risk-free rate, the market returns, the excess market returns, and the returns on SMB and HML. We want to calculate Jensen's alpha. To do that, we first of all need to calculate excess returns for each fund. Let's label this up. Let's name some ranges. So we have the risk-free rate, and we would like to name that RF. We also have some other ranges we should name. We know we're going to be looking at the excess returns on the market when we're running our regression, so let's label this up so it's clear. Let's call this excess or X underscore market underscore rets. And we're also going to look at the three-factor alphas. We're going to estimate the three-factor model of Fama French. So let's select the three factors, which are the excess returns on the market, SMB, and HML. And let's call that 3 underscore factors. Hit enter. Finally, we can also name the range which contains the raw returns for Fidelity and Berkshire. Let's name that range raw underscore ret. Hit enter. We want to calculate the excess returns for Fidelity and Berkshire. So let's select the range where we're going to put those returns. Then go to the formula bar and type equals. It's going to be the raw returns, so raw underscore ret, minus the risk-free returns, which is RF. And then we press Control, Shift, and Enter. And the excess returns for both Fidelity and Berkshire Hathaway will have been calculated. We're now ready to start doing calculations. First of all, let's do some summary statistics. So the average excess returns is going to be equal to average, open brackets, and then select the excess returns for Fidelity. The standard deviation of returns is going to be equal to standard dev, open brackets, and now we have to select Fidelity's raw returns and calculate the standard deviation. In practice, there's going to be little difference between calculating the standard deviation of raw returns and excess returns, but formally we should be looking at raw returns when we're calculating standard deviation. Now let's calculate our Jensen's alpha, assuming we're looking at the CAPM. And if you recall, when we last looked at alphas, we used two functions, index and linest, and that's what we're going to do again. So equals index linest brackets. The known y's are going to be Fidelity's excess returns, comma, the known x's are going to be the excess market returns, x underscore market underscore rets. We want to include a constant, so comma. We will also include statistics, so we type 1. Close the brackets. Now we're looking at where should XL look for the coefficient. It's going to be row 1, column 2, because we've got two factors. We've got the intercept and the market, and they're going to be listed in reverse order. We can now hit enter, and we've calculated our alpha. We also need to calculate the standard error using a similar formula. But this time, to look at the standard error, we need to look in row 2 of column 2 rather than row 1. Row 1 is the estimate, row 2 is the standard error. Again, we hit enter, and we now have the standard error for the alpha. Remember, the standard error is a measure of how confident we are about our alpha estimate. The t-statistic is going to be equal to the estimate divided by the standard error. And we have a t-statistic that's greater than 2. That looks like there is statistically significant abnormal returns. The alpha is significantly different from 0 for fidelity. Now let's look at the three-factor model. Fama French would argue that the three-factor model has more explanatory power than the CAPM. So we should look at that. Maybe this significant alpha that we've generated according to the CAPM, maybe it's not significant after all, it's just we missed the risk factors for SMB and HML. We'll use the index function again and the linest function again. The known y's are the excess returns on fidelity. The known x's now, not the excess returns on the market, but it's the three factors, which we labeled 3 underscore factors. We want a constant included, or the intercept. We also want statistics. Close the brackets. And where are we looking? Well, we're looking in row 1 because we want the intercept. We want the estimate of the intercept. And we're now looking in column 4 because we've got 3 factors plus the intercept. We can now press enter, and we have the 3-factor alpha. Let's calculate the standard error as well. Now we need to look in row 2, column 4. The t-statistic is going to be equal to the alpha estimate divided by the standard error. So we've now calculated Jensen's alpha for fidelity using the CAPM, which is here, and the three-factor model here. The t-statistic in both cases is greater than 2. This suggests that fidelity are earning abnormal returns. What about Berkshire Hathaway? To look at Berkshire Hathaway, we can just copy all our formulas across. So let's select all the cells and then copy across. And everything has been recalculated automatically for Berkshire. And what can we see here? We see that Berkshire Hathaway also seem to be earning significant abnormal returns. The t-statistics are greater than 2. Whether we're using the CAPM or the three-factor model. So for both these funds, there is evidence of statistically significant abnormal returns. Now let's calculate the Sharpe ratios. The Sharpe ratio is the average excess returns on the fund divided by the standard deviation of the returns on the fund. We have these calculations already. We have the average excess returns here and the standard deviation of the returns. The Sharpe ratio is just the average excess returns divided by the standard deviation of returns. Hit enter. Sharpe ratio for fidelity is 14.61%. If we copy that across for Berkshire Hathaway, we see the Sharpe ratio is 18%. How does that compare to the market? We could easily calculate the Sharpe ratio for the market. Let's do that. First, we need to calculate average excess returns. Second, we need to calculate standard deviation of the returns, and then we can calculate the Sharpe ratio. The average excess returns for the market are equal to average, and then let's select the average excess returns, which is 0.0062, so 0.6% per month. The standard deviation of market returns is equal to the standard deviation, and then we select the market returns, the raw returns, which comes to 0.0409, and the Sharpe ratio is equal to the average excess returns divided by the standard deviation, which is 15% basically. Compared to the market, fidelity is very similar to the market in terms of the Sharpe ratio, whereas Berkshire Hathaway is slightly above the market in terms of the Sharpe ratio. How do these funds compare in terms of the Treynor ratio? To calculate the Treynor ratio, we need to calculate the betas for each of these funds. We can do that again using Lin Est. This time we need to look at the raw returns. We're using the market model, so we need to select the raw returns for fidelity. And we're going to regress those returns on the market returns. We want to include a constant, and we want statistics. Close the brackets. What do we want here in terms of the output? Well, we want to be in row 1 because we want to get the estimate of beta. What column are we looking at though? We want the market beta. We want to get a measure of market risk. It's going to be column 1, and the intercept will be in column 2. So we want column 1 this time. Press enter. we now have the beta for Fidelity. We can calculate the beta for Berkshire as well. We just have to modify our formula for the market returns so that the cells don't change as we copy them across. So dollar signs go in. Copy that across. We see the beta for Berkshire is 0.0992. Interestingly, both these funds have very low betas. We know that the market beta is 1, and that means the average stock has a beta of 1, and yet these two funds, which are doing really well, have betas of basically 0. So that's interesting. They're doing something that's different from the market. Let's calculate the Treynor ratio now. The Treynor ratio is equal to the average excess returns divided by the beta. We can copy this across. We have the Treynor ratio for both Fidelity and Berkshire Hathaway. Now here's a problem with the Treynor ratio. The CAPM betas for these two stocks, for these two portfolios, are very low. But the Fidelity beta is almost 8 times smaller than the Berkshire beta. Even though both are very small, the Fidelity beta is still smaller. And this means that the Treynor ratio could be misleading. And we can see now that, according to the Treynor ratio, Fidelity is really doing a lot better than Berkshire Hathaway. But that's not necessarily true. The Sharpe ratio tells us the reverse. This highlights some problems with these measures, and that's why it's important to look at different measures to get a true picture of what's going on. What's the Treynor ratio for the market? The Treynor ratio for the market is actually very easy to calculate because we know that the beta on the market is equal to 1. So we just calculate the average excess returns divided by 1. The Treynor ratio is 0.0062. Both Fidelity and Berkshire have higher Treynor ratios than the market. The final ratio we're going to calculate is the information ratio. This is the most difficult to calculate in Excel. We're going to do it in 5 steps. Step 1, we're going to estimate delta 0 and delta 1. Step 2, we're going to calculate predicted returns. Predicted returns are going to be equal to the estimate for delta 0 plus the estimate for delta 1 times by the return on the benchmark. Step 3, we're going to calculate epsilon. And that's going to be equal to the actual returns minus the predicted returns. Step 4, we're going to calculate the standard deviation of the residuals. That's sigma epsilon. And step 5, we'll calculate the benchmark return. Now let's go back to Excel. The first thing we need to do is calculate delta 0 and delta 1. Let's first name the range for the market so that we can save time with our formulas. If we use the market returns, we'll call them market underscore ret. To calculate the intercept and the slope coefficient from our regression, we're going to have the dependent variable are the returns on fidelity. The independent variable will be the returns on the market, because that's going to be our benchmark. Equals index lin est. Now let's select the returns for fidelity. We know that the independent variable is the market returns, market underscore ret. We want an intercept and we also want the statistics. Close the brackets. We want to look in row 1, column 2 to calculate the intercept value. We now need to calculate the beta, or the delta 1. That's going to be similar. We're going to use index lin est. The y variable is going to be fidelity's returns. The independent variable is the market, market underscore ret, comma, comma, 1, close brackets. We're going to look again in row 1, but we're going to also look for this, beta, in column 1. Close brackets, hit enter. We can do the same for Berkshire Hathaway by dragging the cells across. So we've now calculated the estimates of delta 0 and delta 1 for both Fidelity and Berkshire. Let's name these cells so that we know what's happening. Go to the name box and we'll call this D0 underscore fid so that we know we're talking about fidelity. Now let's select delta 1 for fidelity and we'll call that D1 underscore fid. Now let's look at Berkshire Hathaway and do the same. So I have D0 underscore Berk and D1 underscore Berk. We will need to keep referring to these values when we're calculating our predicted returns for Berkshire and for Fidelity. So let's scroll back up now to the top of the worksheet and do just that. Let's calculate predicted returns. Label things up. Predicted Fidelity return, predicted Berkshire return. The predicted return for Fidelity is going to be equal to the intercept that we've estimated, D0 for Fidelity, plus D1 for Fidelity times by the market returns. And we can press enter. We've calculated the predicted return for Fidelity. If we copy this formula across and then adjust the names so that we're referring to Berkshire instead of Fidelity. We also need to adjust our reference for the market because we've copied the cell across. We're in column G for the market. We now have predicted returns for both Fidelity and Berkshire. We can double click on if we select both cells, we can double click on the bottom right hand corner, and those results will fill down the page automatically. So we've now calculated the predicted returns for Fidelity and Berkshire. The next step is to calculate the epsilon, the error term. So Fidelity epsilon and Berkshire epsilon. The epsilon for Fidelity is going to be equal to the raw returns for Fidelity here minus the predicted returns for Fidelity. Press enter, and we can copy this formula across for Berkshire, and we can check that we're referring to the right cells. So the predicted returns are in L2, that's correct, and the raw returns are in C2, that's also correct. We can now fill this formula down the page by selecting both cells and then double clicking the bottom right hand corner of the selection. We're now up to step 4. We can calculate sigma epsilon now. Why? Well, we've just calculated the epsilons. All we need to do is calculate sigma epsilon, the standard deviation of these errors. So we're going to use the formula equals standard dev, open brackets. Now let's select the error terms for Fidelity, close brackets, copy the formula across, and we have the sigma epsilon for both Fidelity and Berkshire. We've now done much of the hard work. We're almost ready to calculate our information ratio. Sigma epsilon, we can fill out, is equal to M212. So let's get these cells filled out. The final thing we have to do is calculate the benchmark returns. The benchmark returns in this case are going to be what's predicted according to the CAPM. For the CAPM, we would predict that the returns would be related to the average risk-free rate plus the beta for the fund times by the average excess returns on the market for the same period. We need to calculate the average returns for the risk-free rate, which is going to be equal to average, and then select the risk-free rate, close brackets. Let's label that av_RF, hit enter. We also need to calculate the average excess returns on the market, which we've done before, but we'll calculate it again so it's in the same place. And we'll label that, we'll call that the market risk premium. And hit enter. We can now calculate our benchmark returns. The benchmark returns will be equal to the risk-free rate, so the average risk-free rate during this period, plus we need the beta for Fidelity, which we know is equal to 0.0111. We've got that here. Times by the market risk premium. We just hit enter. We've now calculated our benchmark returns for Fidelity. We can do the same for Berkshire. And if we want to format these cells so they look the same as the cells above, first of all let's hit center, and then let's decrease the number of decimal places We're almost ready to calculate the information ratio now, but we haven't calculated the average returns on Fidelity or on Berkshire. The average returns are going to be equal to average for Fidelity, and we can copy that formula across for Berkshire. So we now have the average returns for both these portfolios, and we're ready now to calculate the information ratio, which is going to be equal to brackets average returns for Fidelity minus the benchmark returns for Fidelity, all divided by sigma epsilon for Fidelity, and hit enter. We now have our information ratio for Fidelity. Let's copy this across, and we have our information ratio for Berkshire Hathaway as well. Which fund is doing better then? It's pretty hard to say. The alphas tend to be higher for Berkshire Hathaway, but we know that we can't compare funds based on their alphas. We just know there's evidence that both earn significantly abnormal returns. The Sharpe ratio is higher for Berkshire, slightly, but the Treynor ratio is higher for Fidelity. The information ratio says that Berkshire Hathaway is doing slightly better than Fidelity, but it's a pretty close run thing. There's no strong evidence that one fund is dominating the other fund. Both of them are clearly doing well. That's everything that I want to cover in this video. See you in class.